Okay, so I'm recording now. So I'm going to get started. Let's see, this one. Looks like everyone can see it. That's good. All right. All right. Just make sure it's recording. Okay. All right, so as you can see here, what I want to do, I've posted this as an announcement as well. I want to do a little bit more with rates and unit conversions. The method that the textbook was showing was actually called the factor label method. That's what they say to use in the homework, and I figured it's still good to know that. It is useful, but I'm also going to show another method. Basically, what I'm going to show today is just proportions. You can actually use proportions to solve these kinds of problems. And we'll do a few word problems today as well. And again, I'm hoping to start chapter 3, which is on functions. Okay, so again, this is really just a reminder. A rate, remember, it's really just a ratio of one quantity to another. You know, we saw yesterday 25 miles per hour, right? That's an example of a rate. Another one I said also was when you go to the grocery store and you're buying, say, fruit or something, you know, it's like $1 per pound or $3 per pound. Or if you're buying apples, let's say, you know, it's $2.19 per apple. You know, those are rates. So rates are all around us. And again, it's really just a ratio, which you can really think of as a fraction of one quantity to another. And in particular, we have what's called a unit rate. A unit rate, that's just when the denominator is 1. So as I just said, you know, you're driving a car 25 miles per hour meaning per 1 hour. Usually if you see per in there, like per something, that usually tells you it's a rate. And even like with apples, as I just said, you know, $2.19 per apple, or $2.19 per pound. You know, those are unit rates. If you had something like, for some reason in, I don't know, in the store, if you had, I don't know, $3 per 2 pounds, let's say, I don't know, something like that would not be a unit rate. And now you can actually work with this by using proportions. We have seen, well, if you've taken Math 104, I know with me at least especially, although I know other people do it, equations. You know, equations is just that one statement equals another. A proportion is a type of equation. You're just saying one ratio equals another. That's what a proportion is. And it turns out with proportions, you can use them to solve problems dealing with rates. I mean, these are just some examples of proportions. I mean, here there's no variable, of course, but it's still a proportion. So we have this example, 1/3 equals 3/9. You know, that's a statement that these two ratios are equal. Another one would be this. Okay. And those are just some examples. Now, how do you know when a proportion is true? That is, how do you know when two ratios are equal? It's really from this here. Essentially, you cross multiply, which is really what this is saying. You cross multiply, and if equality still holds, then the proportion is true. So these two are actually true statements. You know, if you did 1 times 9, that would equal 3 times 3. Same thing over here. It turns out if you do 4 times 14, you get 56, which is 8 times 7. Okay. Did it freeze or? Oh, there we go. Sorry, I thought it froze. That's why I paused for a second. All right, let's keep going then. So again, that's really what you want to do. What you want to solve a proportion, you want to use, let me get back to that. You really want to use this statement down here. I mean, basically what's going to happen is you're going to have A, B, C, or D is going to be your unknown. You can call it X or whatever. And what's going to happen is you're going to use this cross multiplying to figure out what that unknown is. All right, there we go. Okay, now let me just make sure it's not frozen. No, good, it's not. I was worried it was frozen. All right, so now we're going to look at some examples of rates. And again, cross products, which is what I was saying before, or cross multiplication, that is how you solve rates. And I just threw in some examples here. These are actually some of the same examples from yesterday. We have 25 miles per hour. You know, usually, again, if you see per here, you have a rate. And in this case, we have a unit rate, right? Even though I didn't write 1 here, it's understood to be 1 hour. Another one, as I said before, with going to the store and buying something, $2 per pound. Okay? These are examples of rates. In fact, these are unit rates. And you can actually flip, yeah?
The PowerPoint's not there.
Oh, crap. You guys can't see it?